All right, folks. A snow-covered ski slope. A snow-covered ski slope makes an angle of 35 degrees with the horizontal. When a ski jumper plummets into the hill, a parcel of splash snow projects to a maximum position of five. Just say height. A height of 5 meters at 20 degrees from the vertical in the uphill. So, so thankfully they draw this as shown in this figure. Find the components of its maximum position. What's maximum position? I'm a little confused about this. So I think I don't remember if I solved this. I know I attempted this, but what we do know is that this guy hits the snow, blumps up, and I guess it blumps up into this little. It goes up to this point at 20 degrees. Oh, that's up here, not vertical. So that's 20 degrees up into that little pathway right there. So let me slant this a little. Let me redraw this. So there we go. So here's the snow. Let's say I'm going to exaggerate the tilt a little bit here. And the snow, it goes up like this. It's not perpendicular to the ground. I don't think it is. So find the component of its maximum position parallel to the surface. Okay, that's what it wants. Okay, now this makes sense. Okay. So this angle right here is going to be 35 degrees. And I really have no idea how to solve this, but I will figure it out. Maybe I'll spend a minute recording this, maybe probably embarrassing myself, but that's generally what you guys have to do when you do these problems. You have to kind of figure them out. So the question is asking, find the component. So I think it's talking about the snow of its parallel position. I think that this is what it wants. So let me redraw this. Let me redraw this little thing. So this is going to be 20 degrees from the thing, and this is going to be at some angle right there. And it wants us to find that little parallel component. So I think I'm going to need to actually I think I'm going to definitely need to pause this video for a bit. I know I'm pretty sure it's pretty straightforward, but and the question is asking perpendicular to the surface. Yeah, I think that's what it is. I think it wants us to find these little components in there. So let's actually redraw this. In fact, before I pause this video, let me do this. Let's draw the snow here. Okay. Let me redraw this. And let's draw this little vector here. And let's find out what this component is. Okay? Because that's what it wants. That's not 20 degrees, but that's what it wants. It wants us to find one of these components and to get that. And we know that this is going to be from the horizontal 35 degrees. We know this is going to be 35 degrees from the horizontal. So, and this is going to be 20 degrees straight up. So there might be a bit of geometry on this one. So all right, folks, I'm going to pause this video. I'm going to pause this video and give this problem a shot. So I'm going to take my time on this. I'm not even going to look at the solution manual for this one. Actually, maybe I will pull that up later in the end. But and this is not a blue problem, so that means that it's pretty, whatever the solution is pretty straightforward. I just don't know what the solution is. All right. I solved it, guys. I believe I did. I'm going to definitely check the solution manual because I'm very curious to see what the solution solves it as opposed to how I solved this. So this is a geometry problem more than anything else, folks. So I'm going to show it to you what's going on. So I hope you guys are not confused about this. So here you have a slope, right? And I'm going to draw the angle right here in blue. So I'm going to ignore the angle from the snow. So the snow will obviously, you know, we'll have at this position at some angle that's 20 degrees from the vertical part. And speaking of that, let's draw this. Let's draw this component as this and this. So notice that I'm drawing it straight up. And remember, this is not perpendicular to the surface, folks. But if you were perceptive, if this is going to be 35 degrees, this is going to be 35 degrees. And since we're going to make a perpendicular pathway right here, so notice what I'm doing, then this angle is going to be 55 degrees, because 55 plus 35 would be 90 degrees. And since this angle is a shared angle, these lines are shared, so this is going to be 35 degrees. This is going to be 55 degrees. And since this is 35 and this is going to be a perpendicular blue line, that's going to be 55 degrees. That's 35 degrees, so therefore this is 35 degrees. Notice the way I drew it, folks. Notice that I drew this as 35 degrees from the perpendicular to the ground. So now we have 35 degrees plus 55 degrees plus 35 degrees. We're going to add that. We're going to establish that this is going to be 125 degrees for the vertical. So this is going to be from here towards the whole ground is going to be 125 degrees, I believe. So this is going to be 125 degrees. But I'm going to draw this right here. What I want is the perpendicular component of this angle right here. So notice that this is going to be 55. This is going to be, oh my god, I lost 35, 55, 35 degrees, I believe. This has to be 35 by geometry standards from the vertical, because this is what we want. We want the component for the perpendicular part of the angle. And now, if you were perceptive, this is really straight from the top. So now we're going to draw this little extra angle, and we know that this is going to be 20 degrees. So what we did is we established that this perpendicular component right here is going to be 35 degrees added to 20 degrees. So 35 degrees added to 20 degrees would be 55 degrees right there. Beautiful! That's part A, and part B being solved right at the top of your head. So no wonder this was a pretty straightforward problem. All you have to do is add the components. But remember, folks, this should be a blue problem. Not because it's so fucking easy to put the math together. The hard part is just recognizing the geometry. Because remember, folks, I don't memorize. Maybe you guys do, but I don't memorize for shit. So I have to figure everything out from scratch. So, but notice right off the bat, folks, that if you pause a little and do a bit of thinking, then you can figure this out too. And you'll realize that this is actually pretty straightforward. Like, this is not hard at all to solve. So there you go, folks. Now we have the geometry. So let's find what now let's actually solve it. The parallel to the surface. So the parallel is going to be this. It's going to be this component right here. So that's going to be 5. That's going to be 5 meters sine of 55 degrees. And this is the perpendicular component is going to be 5 meters cosine of 55 degrees. So 5 meters. So I'm just going to put that in the calculator. So 5 sine of 55 degrees is going to be 4 point. I know this is going to be the correct answer. I'm not even like going to try and convince myself. About 0.49 or 410 meters. I'm not even going to round there. 2.87 meters. That's going to be the values that we're going to find. Now, I know I solved this, but I am going to pull up the solution and see how the solution says this. I'm very curious now. All right, let's pull that up. Right. All right, guys, let's look at the solution manual to see how they solve it. I know I solve it different. from the solution manual. And to be honest, I have no idea how the solution manual even solves this. And I don't really care. I mean, like, my brain just is already shut down when even I look at this. So, but you guys can try and figure this out geometrically. So we take the y-x-axis along the slope of the hill. A student get used to this choice. The y-axis perpendicular to the slope at 35. Then the displacement of the snow makes an angle of 90 degrees minus that, 35 degrees minus 20 degrees with the x-axis. Awesome. So, whatever. I don't. It gets the same results anyways. So apparently, 5 cosine of 35 degrees. It's the exact same thing as 5 sine of 35 degrees apparently, and 5 sine of 35 degrees is the same thing. Oh wow, they do match. Okay. So I did solve this differently from the student, but you guys can solve it however they want. It really doesn't matter. 35, so 90 minus 55 degrees would conveniently equal 35 degrees regardless. So so whatever. So its components parallel to the surface is that, which is the answer that I match in the back, and this component is perpendicular to the surface of that. So notice that I drew the geometry part of just saying that, okay, this is going to be 55 degrees. Or what did I do? Added to 35 degrees, added to 20, which made this a 55 degrees. And I just kind of drew the components perpendicular here and the parallel there, and took this as the magnitude and just got the result from there too. And realistically, folks, you could solve it however you want. You don't have to use my method. I mean, it's really the same thing. More than anything else, your teacher will mark it correctly. Most of them do, unless they're dumbasses. But usually at this level, you should have smart professors out by now, so that shouldn't be an issue for you guys. Anyways, folks, I know I'm ranting, but I'm gonna stop here, and I hope you enjoy this. Let me know what you guys think in the comment sections below, and give any suggestions, to improve this channel and help this channel grow.